That's a fact. So the developing fetus is exposed to whatever is in the mother's bloodstream. And all of these metals get into the bloodstream and pass through the fetus. We know that there are developmental effects, brain nervous system effects for lead, respiratory, reproduction, kidneys, heart and circulation, bones, skin, endocrine and cancer effects. We know not quite as much about nickel. We know quite a lot. We know that it's a carcinogen. But some of these other non-cancer effects are less well understood, particularly in children, because it's not a priority. A lot of what we know about metals comes from occupational health studies, looking at workers. But obviously, a child responds very different to contaminants because its organs are developing, it's more sensitive, the children breathe more quickly than adults do, they eat more, they drink more. So their body's response to metals is going to be very different than adults. But a lot of the assumptions underlying exposure is based on looking at adults. And that's one of the flaws of health risk assessments. This is a summary of what we know, without a doubt, are the impacts of lead on children. We have deficits in reading, mathematics, language skill, perception and motor functions, deficits in reaction time, attention spans, non-adaptive classroom behavior. Just a recent study, they found that children who have higher blood lead levels, if you track those children over time, they're much more likely to get involved in delinquent behavior, criminal even behavior. That's a fact, because it has such profound effect on cognitive learning abilities and attention spans and ability to emotional development, etc. They are at significant risk of learning disabilities, speech and math, failure to complete high school. There's grammar, all of these, poor hand-eye coordination. All of this happens when blood lead levels are below 10 micrograms per deciliter. And 10 micrograms per deciliter is the level that Health Canada currently considers safe. The Journal of Pediatrics and Adolescent Medicine in 2003 did an entire issue on children's health and contaminants. And basically their statement on lead is that there's devastating impacts even at low levels. And this is simply the results of the most recent study by Todd Jusko and Richard Canfield and Bruce Lamphere. These are really the preeminent experts on lead and its impacts on children and IQ in the United States. And essentially, the point of all of this is to say that their findings are consistent, that IQ measures in children that have blood lead levels between 2 and 5, the greatest drop in IQ occurs when those blood lead levels are reported in children. But essentially the point they're trying to make is that at 10 micrograms per deciliter, which is the level in the United States as well, that is not protective of children's health because they are seeing that at the lower levels of blood lead levels, the low levels below 5, is when a lot of the damage happens. And it makes sense from a physiological perspective. It's when children, between 2 and 5, when a lot of their cognitive brain functions are developing. It's when lead has its most critical and crucial impact. In fact, Health Canada has been sitting on a report from a working group they convened at least 5 years ago, if not longer. They are contemplating changing that level of 10 down to 5. I've been waiting 2 years under a right to information request. I want that report. I know it's recommending 5. My question is, why are they sitting on that report, and why are they not implementing or instituting a new blood lead guideline for children? And that report is going to recommend 5. And I also know that a lot of the consultants who have been working for, whether it's Xstrata or Vail Inco, have also been sitting on this working group of Health Canada. We need that report. We need those recommendations to be immediately implemented. This is the pattern. This is how it's the lead levels in blood that were deemed acceptable, how they have changed over time. Right now, we know it should be 5, but in fact, it should be 0. But in order for that to happen, it's going to take another 10 to 15 years, because you can see that the pattern here is it takes about 10 years, even though the science is well ahead of what the regulators are doing. 60 used to be considered a safe level for kids. Today, it's going to be 5. And 10 years from now, it's going to be 0. So although the recommendation may be 5, we should be thinking 0. And when we're thinking about the health risk assessment and its recommendations, we should constantly be thinking about the future, not only about today. In Belledune, we've got the highest blood lead levels, and they're higher than Port Colborne, which you would expect. It's a lead smelting community. This is just an indicator that there is obviously a problem. Blood lead levels aren't 0. They're not even 1. They do range as high as 12 and 16. So the call for doing a blood lead study in Sudbury is absolutely essential. How much lead in soil is considered safe? Scientists agree that every 100 parts per million in the soil raises the blood lead level 1 microgram per deciliter. So to me, it's not surprising that the Canadian Council of Ministers recommends 140 as the safe level. Not 200, not 400, not 500. It's 140. If you apply this formula, 100 parts per million soil, 1 microgram per deciliter, you are looking at having children with about 1.5 microgram per deciliter. It's still below 2, it's low, but it's better than anything higher. The acceptable and the remediations levels vary across jurisdictions. What Ontario deems safe, what Alberta deems safe, what British Columbia, New Brunswick, varies across jurisdictions for various reasons. Alberta uses the CCMA guideline of 140. The only time they require a risk assessment is if the property owner won't clean up the property. So 140 is good enough for Alberta. California has used 130. The Oregon Department of Environment, the maximum they'll allow, not the minimum, the maximum is 200. And the Ontario Ministry uses 200 as a starting point. But what you need to remember is that every 100 parts per million of lead in the soil that you allow increase will raise the blood lead level of children 1 microgram per deciliter. So how are health risks estimated? Well, there are various methods. One is to look at blood uptake. And this is what's been done in Port Colborne and in Sudbury. It's called the IEUBK model. The other two ways don't deal with blood lead level. They talk about cancer risks, and they talk about what are called hazard quotients. Hazard quotients are the non-cancer effects. It's a ratio of the calculated dose to the permissible dose. And if that can be anywhere between 1 and 0.2. The lifetime cancer risk that's acceptable is 1 in 100,000 or 1 in a million. It depends on the jurisdiction. So the basic risk assessment approach. To measure risk, you've got to know how much contamination is in the soil, how much is in the air,